Okay. So today our focus will be on shifting sine and cosine. Okay, both horizontal and vertical. Okay, horizontal and vertical. And so we'll start with the, I don't say the trickier one, but we'll start with the horizontal shift first. Okay. Because accounting for that horizontal shift is actually pretty similar to what we did yesterday with accounting for the change in the period, like a stretch or a shrink of the period, right? Okay. This is the same idea. That same kind of calculation will also account for any sort of horizontal shift. So we can simultaneously take care of period stretching or shrinking and shifting left or right then too. So the way we can kind of tell that we have a horizontal shift when we have our equation is, well, we know that the A, right, that in front, the A is going to be standing for the amplitude, that we saw that yesterday, but then it's what we have inside here. Okay. The B here is going to indicate that we have some sort of period stretch or shrink. So instead of going from 0 to 2 pi, instead of that traditional 2 pi length of the period, that's going to either stretch or shrink that period, the B will. But then C, that's going to adjust whether we shift left or right. Or we're going to then, on top of stretching or shrinking the period, whether we move it left or right. So when you see like a plus or minus C here inside the parentheses, that's going to indicate a shift left or a shift right. Okay? It doesn't always translate exactly to shifting it right C units because it depends on the period stretching or shrinking too. And we'll talk about that. And then of course, you know, cosine is the same way. If you see that bx and you have like a minus c in there, that's going to indicate there's a horizontal shift as well as, you know, period stretch or shrink and then an amplitude, vertical stretch or shrink. Okay. And the key thing to do here, like I said before, like I said yesterday, when we had kind of this stuff in parentheses other than x, the key thing was to start with the traditional 0 less than or equal to, and then we'll put the bx minus c there in the compound inequality, okay, and just kind of calculate that, okay, and that's going to be kind of our key step here to kind of making the adjustments necessary to do our graph sketch. Okay, we start with the 0 to 2 pi, and then we just solve for x here to then get that get the x by itself and get our new period. New period length, new period start and stop point too. So let's see an example here. What I mean, and we'll start with a real basic one. Y equals the cosine of x minus pi over 3. Okay. So this one's nice, right? The amplitude is just going to be what? 1, right? Okay, it's a positive 1 for the cosine there. That's right. There's no period stretch or shrink, so we still would expect our period length here to be 2 pi, right? There's no coefficient with the x there, so the period length should still be 2 pi, but we are going to have a horizontal shift. So here it's very easy to read this horizontal shift. We're going to be shifting right pi over 3 units. So whereas we normally start at 0, we're now going to start at pi over 3, and where we would end at 2 pi, we're now going to end at 2 pi plus pi over 3, which would be, what, 7 pi over 3, I think? Okay. But again, let's do that actual calculation here. So we'll take this shift and we'll put it in between our normal 0 and 2 pi. Okay, so there's our normal kind of period. And then we'll just solve for x to see the adjusted period. And so we add pi over 3 to all 3 sides here, and we're going to get pi over 3 less equal to x, and then less than, so again, 2 pi plus pi over 3 is going to be, I guess I'll just do this calculation out here to the side, right? 2 pi plus pi over 3, they're not like terms, they're not common denominators, but 2 pi is the same thing as 6 pi over 3 plus a pi over 3, which gives us then that 7 pi over 3. Okay? Don't be scared that, you know, our fractions now have like pi's and stuff in them. Still the same idea. Get a common denominator, combine like terms. Okay? 2 pi is 6 pi over 3 plus pi over 3 is 7 pi over 3. And so there's our new kind of like initial period. We're actually going to start at pi over 3 and then go out to 7 pi over 3. Okay? So that's it. So now we're just going to graph it. So when we go to graph this, a key thing here, right, we're still going to put the 1 and the negative 1 there. Okay. Oops. There we go. Okay. So still kind of, started out, right, we know the amplitude's going to be 1. In this case, though, we're not going to start at 0, so we need to kind of like go out a certain distance here and say, we're actually going to start at pi over 3. So that's going to be our actual starting point there is pi over 3. Okay, and then we're going to go out to 7 pi over 3, so I don't know, I'll say that's like right here. Okay. So that's 1 full period, but of course, traditionally we're asked for like 2 full periods, so let's do 2 full periods here. Let's do 2 full periods. Okay, so let's graph 2 full periods here. So there's 1 full period, right, starting at pi over 3, ending at 7 pi over 3. So how can we know then how much further we need to go out to here? How much further? So from pi over 3 to 7 pi over 3, well, that's a distance of, well, what is that distance? What is the distance between pi over 3 and 7 pi over 3? What's the length there between those two? 2 pi. Yeah, how can we calculate that? Yeah, exactly right. Take your right endpoint here, subtract your left endpoint. 7 pi over 3 minus a pi over 3, that means it's a length of 2 pi, or 6 pi over 3, right? 6 pi over 3 or 2 pi. So we'll go out another 6 pi over 3 from 7 pi over 3, right? Go out another 2 pi here from 7 pi over 3. Let's go out. So that'll be 13 pi over 3. Okay, so something like that. All right, so there's going to be our first full period between these two, and there will be our second full period between these two. Okay. So again, we could talk about, this thing being a period, but also the length of this thing. You can also describe the period as being the length. And so Cole would say, as Cole said, right, the length here is 2 pi, so you could also say the period is 2 pi. It repeats every 2 pi. So it starts from pi over 3 to 7 pi over 3, and the period length is, 2 pi. Okay, period length is 2 pi. Okay, bless you. So now let's go about getting the other points that we need between here. And it's the same kind of idea we did before. We start with our starting point and stopping point, and we find the midpoint here. So we want to find the midpoint between those two, and then we'll find those quarter kind of the way points. So halfway between pi over 3 and 7 pi over 3. We want to find the midpoint again, just add them up. Pi over 3 plus 7 pi over 3 is 8 pi over 3. Divide that by 2. 8 pi over 3 divided by 2 is 4 pi over 3. Okay. 4 pi over 3. And then to find the midpoint between these two, add them up. Pi over 3 plus 4 pi over 3, 5 pi over 3. Okay. But now 5 pi over 3 times a half, right, divided by 2 or times 1/2, that's going to be 5 pi over 6. Okay, 5 pi over 6. And then same thing with the 4 pi and 7 pi, add them together, so that's 11 pi over 3, divide that by 2, it'll be 11 pi over 6. And we'll do the same thing here for 7 pi and 13 pi. So 7 pi plus 13 pi is 20 pi over 3. With divided by 2, then it'd be 10 pi over 3. Okay. And then add those together. 17 pi over 3 divided by 2 is going to be 17 pi over 6. And then the last one here will be 23 pi over 6. Okay. So there we go. All of our little numbers there. Okay, any questions so far about where any of those numbers came from or how we know to do those numbers? Anything so far? We're all good? So far, so good? Okay. So again, we're going to start at pi over 3 here. All right, if we remember, we can actually, if you want to, you could plug in each one of these numbers, plug each one of these in for x, subtract pi over 3, and then take the cosine of that. You can do that. In fact, let's do that to start here. We'll start at the pi over 3. I'm not going to start at 0 because we shifted here. I'm going to start at the pi over 3, which is fine. You can do that. Okay. Plug the pi over 3 in. Pi over 3 minus pi over 3 is 0. Cosine of 0 is what? Cosine of 0 is 1. So cosine of 0. Well, it's pi over 3, so it's cosine of pi over 3. In this case, cosine of pi over 3 minus pi over 3. So it's going to be at pi over 3, we're going to get 1. Okay. At pi over 3, We're going to subtract pi over 3, so it's 0, so it's really evaluating like cosine of 0 here. So that's 1. Okay. Imagine plugging in that pi over 3 makes 0, cosine of 0 is 1. All right, now 5 pi over 6. Well, if we kind of follow the traditional path, so we could plug in 5 pi over 6, subtract the pi over 3, and then evaluate cosine there. Okay. Spoiler alert, 5 pi over 6 minus pi over 3 is pi over 2. Cosine of pi over 2 is 0. Okay. Same thing with 4 pi over 3. 4 pi over 3 plugged in here is going to be just 3 pi over 3 then, which would be cosine of pi, which is negative 1. And so you can kind of see it's going to follow the normal pattern of cosine. We're going to start up off the axis here at 1, go down to 0, then to negative 1, then 0, then back up to 1, and so on and so forth. And you can kind of just follow the pattern. Once you get the hang of the pattern, it's not necessary to like plug all these numbers in and stuff like that. Okay. And so then we'll just sketch our curve. Okay, like that. Okay. And so there it is, 2 full periods. All right, I'll kind of like, you don't need to draw on this dotted line here, but there you can see the 2 full periods, right? There's 1, 2. Okay. Questions on any of that? All right, but I'm going to have you guys try one here. All right, so how about you all try y equals the sine of x plus pi over 2. Okay. So you go ahead and try that one. Try the y equals sine of x plus pi over 2. And graph that. Again, graph 2 full periods, please. zeros are right here. Okay, gotcha. So that does work. That is 2 full periods on that graph. So far, so good. Yes. So your full period's going to go from here to here at this point. So you have to figure out that end point. Yes. Yes. So yes, that's right. So you need you found the midway point, right? So then you found the midway point between these two, right? The quarter points kind of thing. So add those together, it's 0. Right? Divide by 2, it's still 0. So actually that's going to be your quarter point right there. So you may want to like shift this part over just so they're, because they're both pi over 2 away, so the same. And then find your midpoint between these two. Again, so add them up. So yeah, pi over 2 plus 3 pi over 2 is 4 pi over 2, which is really just 2 pi. Half of that would be pi, like we said. Yeah. Correct. So yeah. So again, the length of this from here to here, that's a distance of 2 pi, right? You can do this minus that, but it's like 2 pi. So you can go 2 pi out, which is 4 pi over 2. So adding that to 3 pi over 2 is 7 pi over 2. Does that make sense? And then again, halfway point is the word. Yeah, that should be the thing. Oh, so remember you're subtracting pi over 2 from both sides to solve. That should be a negative pi over 2 there. That should be 3 pi over 2. Yes. I have no idea. Yeah, I don't know. I think it's default to that right now, which it shouldn't be. It is. Can you change the? You can't change it. They did put grades in too. So we have some old grades too, right? That is weird. Thank you, Elizabeth. Excellent work. Anyone have questions over here? All good? All right, so let's take a look then. So there is the graph. Okay, amplitude's 1. Period length is still 2 pi, right? We didn't stretch or shrink it at all here because there's no coefficient in front of the x, so that indicates that. We just have a shift to the left, pi over 2. So whereas we normally would start at 0, we're now going to start negative pi over 2. Whereas we would end at 2 pi, we're now going to end at 3 pi over 2 for that initial period. Okay, and so there's what it looks like. Questions on any of that? It's all good? All right, then let's talk about a vertical shift, and then we'll put it all together. Okay, then we'll put it all together. So, the last little bit here, a vertical shift is a little bit easier to account for than that horizontal shift. Oh, vertical change. Whoops, vertical shift, sorry. Okay, so vertical shift. What does that look like? So now, here's what we can account for. We have the amplitude, right? That's the A, that's in front of the sine or cosine. We have this bx minus c, which accounts for both a potential period stretch or shrink with the b there, and then also a shift left or right with the minus c. And then lastly, we have this plus d at the end, and that plus d is going to shift our entire graph up or down, d by d amount, okay, by the amount d there. Okay, and then again, likewise with cosine, it's the situation. The A is the amplitude, the absolute value of A is the amplitude, the bx minus c is going to be a period stretch shrink, and then also a shift left to right, and then the plus d at the end to shift it up or down. Okay. Which again is no surprise there, right? We've seen plenty of transformations. You guys have seen plenty of transformations now with different functions where you add a number on at the very end there, and it goes up or down. The graph changes, it goes up or down by that much. Okay. So just real quick here, I'll show you an example of this, and we'll just kind of put it all together. So y equals cosine x plus 4, we'll say. So again, it's not cosine of x plus 4, right? There's no parentheses around this. It's cosine x and then plus 4. Okay. There would be parentheses around the x plus 4 if that was all in the cosine. It's really just cosine x and then plus 4 added onto that. Okay. So the amplitude here is still going to be 1, right? The period length is still going to be 2 pi. Because again, the x there, right, there's no number in with the x, so the period length is going to be the normal 2 pi length. It's going to start at 0 and go to 2 pi again. It's just going to be that plus 4. It's going to shift things. And so when we go to do our graph here, we want to be a little crafty, a little bit, plan ahead, I guess. We want to think about how this is going to work. So since we're shifting up 4, all right, since we're shifting up 4, that means I want to focus, when I'm doing my graph, I want to focus mostly in that first kind of quadrant above the x-axis. So when I go to, set up my graph, I'm not going to stick my y-axis right through the middle here. Instead, I'm going to kind of shift my y-axis down some, like this. So that way I can, kind of account for the full graph of the cosine. So it's going to be, up 4 off the axis. Okay. Now, my recommendation to you, and you don't have to follow this, but I just find that it kind of makes things easier. It can be a little bit disorienting when we do that vertical shift there, plus 4. I mean, maybe it's disorienting for all the shifts that we do, but it's helpful. There's like an easy way to kind of account for that vertical shift. Okay. So first thing I want to talk about though is, since we're shifting up 4, okay, what is the highest y value that we could now have? Originally, what's the highest value that cosine can achieve? 1, right? The highest value you can achieve is 1. If you shift that graph up 4, now what is the highest value that cosine can reach? 5, right? 1 above the 4. 4, you think of like your 0 line, so we can go up 1 from that. And so the lowest y value you can reach when we shift it up 4 is then 3 down below that. Okay, so that's why I went up to 5 and down to 3. Okay, yes, it's shifting up 4, but because then the cosine goes up 1 and down 1 from that kind of center, we need to go up 1 from 5 and down 1 from 3. So again, that means if your amplitude changes, for example, if your amplitude is 2 or 3, right, you got to account for that. If our amplitude was 2 here, then I would need to be up to 6, right? I'd be going down to 2. If my amplitude was 3. Again, I'm shifting up 4. If my amplitude was 3, I'd be going up to 7 and down to 1. If my amplitude was 10, I'd be going all the way up to 14 and all the way down to -6. So these are things you want to keep in mind when you're, again, setting up your graph there. That amplitude is also going to affect, what needs to be on your x-axis, or your y-axis as well. Okay, so we're good, though, because it's just shifting up 4 and our amplitude is just 1. What I like to do is kind of draw in a dotted line here just for my own kind of visual benefit, so I can remember, know where the new 0 is. Okay, it's the new 0, it's the shift up there. Okay, so this is the new x-axis for me. I'm still going to label my coordinates along the x-axis down here, so 2 pi, 4 pi, okay, and then pi over 2. Okay, so this doesn't change down here. So our period length is still 0 to 2 pi. Our period is still 0 to 2 pi, and so then we, period length 2 pi. Find those halfway points and the quarter points of the 2 full periods. Okay, and again, you can start if you want to with, just plug it in 0. Cosine of 0 is 1 plus 4 is 5. And so our first point here at 0 is going to be 5. You can plug in pi over 2. Cosine of pi over 2 is 0, plus 4 is going to be 4. Cosine of pi is -1. -1 plus 4 is 3. But again, you kind of get an idea. Okay, so we were above the, right, cosine always starts above the axis, and then on the axis, and then below the axis like that. So, you know, we can see the next thing we're going to go to, at 3 pi over 2, we're going to be back at 4. Just kind of following pattern. At 2 pi, it's now going to be above, at the 5. 5 pi over 2 is back on the axis. 3 pi is back below the axis. 7 pi over 2 is back on it. And then 4 pi is back above. Okay, and then just connect the dots. Just like that. There it is. And again, you can, like, you know, I'll put the dotted lines there to indicate it keeps going, right? But we just grab 2 full periods. And there it is. Shift it up 4. Okay. Questions on any of that? Straightforward? Good? Too easy? All right. Not too easy. Just easy enough. All right. So now, let's put it all together. Everything, okay? Everything. All right, putting it all together. Here we go. So, this doesn't quite include everything, but includes many things. Okay. So right away we see the 3 in front means our amplitude, right? Our wave is going to be now height of 3 and a, you know, like a lower point, or like a go up to 3 and then down to -3, right? We're going to be shifting up 2 as well, so that's going to account. That's going to affect things as well. And then sine of 2x, that's going to stretch or shrink our period there as well. Okay, so we're not shifting left or right at all. That's the one transformation we're missing here. There's not like a, you know, in with the x here. There's not like a +3, you know, pi, or plus pi over 3 or anything like that. So it's just a stretch or shrink of the period, and then shifting it up 2, and then we have an amplitude of 3. So we only got 3 transformations here, not all 4. Okay, so let's again identify things. So again, the amplitude is amplitude 3. Okay, we're going to have to figure out what our new period is going to be here, so we'll put that 2x between the 0 and the 2 pi to figure out, you know, how's that 2x going to affect our period there. And so we'll divide both sides by 2. We get 0 less than or equal to x less than pi. So now our new period length is just pi. Okay, the period length is just pi. It goes from 0 to pi now. We cut it in half. We shrunk it. Okay. And so now we're pretty much ready to graph here. So again, I want to take into account some things here. I'm going to be shifting up 2. And I'm going to have an amplitude of 3. So again, I'm going to kind of like be a little bit higher off my x-axis than, you know, than right in the middle. So again, I'm not going to put my y-axis or my x-axis right in the middle here. I'm going to put it down a little bit. Okay, we're still starting at 0, so I don't need to include too much in the, you know, to the left here. But I do want to include more above the x-axis because we're going to be shifting up 2 here. Okay. What's the highest y value? What's the highest y value that we need to have on our y-axis here? What's the highest? Spencer? 6. How'd you get 6? Well, remember, so we're not going to go up by 1. If we go up by, the 3 there is going to affect. So it's really just going to go up 3. So how high do we really need to go then? Not 6, but we go up to 2. So 2 is like our new center, our new axis. And then from that axis, our amplitude means we're going to go up 3 from that. So just the 5 is all we need to worry about, yeah. So we need to go up 3 from the 2, down 3 from the 2. So up 3 from the 2, we need to go up to 5. Okay. Is everyone clear about why we need to go up just up to 5 there? Are we okay with that? Just the 5, so we need to go up to there. Okay. And so again, I'll try to draw in my new 0 through the 2. Okay, just like that. So that vertical shift to 2. So 0 to pi, that's going to be 1 full period right there. 1 full period, 0 to pi. And then I'm going to go out, again, we'll do 2 full periods, so I'll go out pi more to 2 pi. So that's going to be 1 full period right there, and then we'll have another full period right there. So again, once you've got that set up, now you can find the halfway point, so pi over 2, and then the halfway of the halfway, the quarter points. Whoops, so pi over 4 and 3 pi over 4. Okay. And then halfway between pi and 2 pi is 3 pi over 2. And then the halfway of the halfways will be like the 5 pi over 4 and the 7 pi over 4. Sometimes these angles will be angles that are on the unit circle. Sometimes these angles, the x-coordinates will not be something that's in the unit circle. When you plug them in and evaluate them, they'll end up being things on the unit circle. But as they're currently written, they may not be. In this case, they all are, but they might not always be. So you got to be comfortable with doing all those calculations. All right, so now we'll start here. Sine, we're going to graph sine. Okay, we'll start at the 0 because that's where we want to. That's where our period starts. There at 0. So plug 0 in. 2 times 0 is 0. Sine of 0 is 0 times 3 is 0 plus 2 is 2. So at 0, we're going to have a point at the 2 there. Okay. At pi over 4, well, 2 times pi over 4 is pi over 2. Sine of pi over 2 is 1 times 3 is 3 plus 2 is 5. Okay. If you just use the patterns, that's okay, folks. That's fine. If you remember that sine starts on the axis, right? So here it's going to start at the 2, and then it's going to go up. In this case, the amplitude of 3, and then back down. So we should understand here the next point here is going to be back on the axis, and then 3 pi over 4 is going to be down 3, so that's going to be at the negative 1. Oops, which is going to be like in the middle of that graph there. Pi back on the axis, 5 pi over 4 back above at the 5. 3 pi over 2 back on the axis, 7 pi over 4 back at the negative 1, and then 2 pi back on the axis. Okay. So again, you can just use the patterns there to help you get that. You don't need to plug every single one of those in. But there it is. Okay. Questions on any of that? I want to do one more. Just to make sure we're all good. I'd like to do one more. All good? Can I move it? Scoot it up maybe? Okay, so the next one here, if you're feeling confident, you can feel free to jump ahead. Maybe you already have been jumping ahead. That's good too. So for this last one here, we can see it's written in a bit of a different way than we're used to. We have 1 minus 2 cosine of x minus pi over 4. Okay. I don't really like how that's written because we have the 1 minus the 2 cosine there, which is a little bit weird for me. So I'm going to rewrite this as negative 2 cosine of x minus pi over 4, and then put the plus 1 at the end. Okay. So instead of 1 minus 2 cosine, it will be negative 2 cosine of x minus pi over 4 plus 1. And this more clearly shows to me, okay, what's the amplitude, what is the, you know, the vertical shift, all that good stuff. Okay, so there's our second one there, our last one. All right. So, what is our amplitude here? What's the amplitude for this? 2. Good. The negative's important. The negative's important, right? But the amplitude is 2. The distance, the length there, the height of the wave is going to be 2. All right, let's figure out what this period is going to be here. So we're starting between 0 and 2 pi, but we're going to put that x minus pi over 4 in between. Okay, and then solve for x here. So we'll add pi over 4 to all three sides. You get pi over 4, x, and then 2 pi plus pi over 4, 9 pi over 4. Okay. And yeah, you guys hit on the head over there. There are parentheses here, so that's how we know the x and the minus pi over 4 go together, whereas before on the last one, it was not the case. The 2x and that plus 2 was a vertical shift on the outside, okay? So yeah, that's the idea. It's just the 2x was in the parentheses there. Really. Okay. But there's that. All right. So now we're going pi over 4 to 9 pi over 4. So we'll go to graph this. Now here I can see we're going to shift up 1, but that amplitude of 2 means you're going to go 2 above 1 and 2 below 1. So I need to I'm just going to kind of leave it roughly in the center right now anyway, so when I go to graph this thing. Okay. Alright, so there's 1. I need to go 2 above that, so 2 and then 3, and 2 below, so that, and then there's negative 1. I'm going to put negative 2 and negative 3 as well. Okay. So my new x-axis is going to be up 1. That. Okay. I'll just go out some distance here, and I'll say that's a distance of pi over 4. And then we're going to go out somewhere here to like 9 pi over 4, we'll say, is right there. Okay. But again, let's say we want to do 2 full periods here. So I need to go out an additional, we need to figure out here, what is our period length? Okay. What is the period length here? What's that distance? From pi over 4 to 9 pi over 4, what is that distance? What's the length there between pi over 4 and the 9 pi over 4? Well, subtract them. 9 pi over 4 minus pi over 4 is 8 pi over 4, which is just 2 pi. So the length here, the period length is still 2 pi. It's just been shifted over, so it's harder to see. So if the distance between these two is 8 pi over 4, we'll go another 8 pi over 4 out to then 17 pi over 4. And so then we'll find our halfway point here. So to find a halfway point, we're going to add these two together. Pi over 4 plus 9 pi over 4. It's 10 pi over 4. And that'll be really 5 pi over 2. But divided by 2, it'll be 5 pi over 4. Okay. And then the halfway point of the halfway points here. So pi over 4 plus 5 pi over 4 is 6 pi over 4, which is really 3 pi over 2. Divided by 2 is 3 pi over 4. Okay. You can also kind of see like patterns in this as well, right? So it's like up 2 pi over 4, up 2 pi over 4, so up another 2 pi over 4 is going to be 7 pi over 4. And up 2 pi over 4 is 9 pi over 4. And then you kind of do the same thing here. We're just going up by 2 pi over 4 every time. So you say, oh, it's 11 pi over 4 here. This is going to be 13 pi over 4. And this is going to be 15 pi over 4. And then 2 pi over 4 more. Look, we're at 17 pi over 4. So there it is. it is all set up. Okay, and so then the last bit, here we go. Now we're ready to finally start graphing. We have all of our preparation done, now we can start graphing. So cosine, again, it's up to you how you want to determine this, right? Cosine, you know it's the one that starts off the axis, right? Normally, a normal cosine is just one above. Because it's -2, we're not going to start one above, we're actually going to start 1, 2 below. So you could just put the point right there. Alternatively, right, if that's too much to like think about, you can also imagine plugging pi over 4 in here. Pi over 4 minus pi over 4 is 0. Cosine of 0 is 1 times -2 is -2 plus 1 is -1, and so there's your point. Pi over 4 -1. You can do the same thing with 3 pi over 4. 3 pi over 4 plugged in minus pi over 4 is going to be pi over, or 2 pi over 4, which is pi over 2. Cosine of pi over 2 is 0 times -2 is still 0 plus 1, so we're back on the axis there. And then 5 pi over 4, well, hopefully at this point you can get the idea, but if not, that's okay. 5 pi over 4 minus pi over 4 is 4 pi over 4, which is pi. Cosine of pi is -1 times -2 is +2, plus 1 is 3. So now, hopefully you see, we're going to go up, up, and then back down here to this axis, and then back down here to the -1, back up to the axis, back up to 3, down to the axis, and then back down to the -1, and we're done. Okay, and so we finish graphing these lovely little sketches here. And there it is. Okay, 2 full pages. Questions on any of that? You guys have been really great. I apologize for how much this was. I know it seems like a lot, but that's, you know, we had to get through this here. So this was more painful than usual, I'm sure, and I apologize for that. But that's all. Okay, so this will, up to this point now, will be on tomorrow's quiz, potential fodder for tomorrow's quiz. Okay, so there could be 1 or 2 like this, 1 like this, yes. Not all of them will be like this, no, not all. Not all. But there could be 1 like this, yes. Absolutely. So if you want to come in for set, get some extra help, I'll be happy to do that. Okay. Let me give you guys your assignment here.